Okay, so first of all, that is as far as we got on that first example. We're on page 3 of the notes here, solving equations, correct? I will go turn your lights down a little bit here. And now hopefully you can see the screen a little bit better. Our first task was we need to take this equation and make it equal to 0. So I chose to subtract my 11x squared and my 10x over so that my lead term, the 6x cubed, was positive. And then we had a GCF of x. And that's what we did right here, yes? We factored out x, and then we were left with 6x squared minus 11x minus 10 equals 0. And then we were talking about how do we factor this trinomial that's in the parentheses. And because there's an a term, we had to use product of AC.
Yes.
So 6 times negative 10 was negative 60. Sum is always that middle b, so negative 11. And we came up with 4 and negative 15. After I think I followed Stella's wrong lead briefly. So, hey, I'm guilty too because I followed. So we took, and this is about where I ended, that 4 and negative 15 we came up with. We used those to split the middle term, yes? And then what about the first and the last term? Those are just going to drop down. So 6x squared just carries down. Minus 10 just carries down. And my equation looks like such. Okay, are we up to speed?
Yes.
Yeah, who's he subbing for today?
Stanley.
That's why I hear him so well. Okay, first of all, don't forget this x out front has to carry along. Do not lose it or you lose an answer.
Oh, lost it.
Don't want to lose it. Okay, so now what I'm actually going to do is I'm going to do like a big set of brackets just to kind of set off the rest. Do you remember how to do this? We have 1, 2, 3, 4 terms.
Split them in half.
When there's 4 terms, split them in half, looking for the GCF of the first 2. What's the GCF of 6x squared plus 4x? 2x.
2x.
So I'm going to have 2x, parentheses. What remains when I factor out 2x here?
3x plus 2.
3x plus 2.
Period.
In parentheses. Now, GCF of my second 2. GCF of minus 15x minus 10. Minus 5, negative 5. If nothing else, because that 15x term is negative or minus, use a negative. So we're going to do minus 5. Parentheses, what remains after I factor out the minus 5? 3x plus 2. In parentheses, in brackets, it all still equals 0. My 0 is going off the screen. Okay. The x out front, again, don't lose it. Carry it down. Yes?
I thought the 10 had an x at the end on it.
Oh no, because we factored out the x's.
The 10 had an x up here when it was 10x. But then, in this step right here, I factored out GCF of x.
Oh, that's
And so now it's just a 10.
true.
Okay. This x out front, just keep carrying it down. And then what's the idea with what we just did? We rewrite this into 2 parentheses.
It's going to be 2x minus
1 parentheses is your GCFs. My GCFs were 2x minus 5. The other parenthesis, my matching parentheses, which if they don't match, go back and see where you went wrong. But it's 3x plus 2. I would like to argue that you can finish this one.
Yep.
Now, the difference is instead of just 2 parentheses multiplying to equal 0, I have 3 things multiplying to equal 0. What do? Set each part equal to 0, right? So we have x equals 0, 2x minus 5 equals 0, and 3x plus 2 equals 0. How much work do I need to do from here for you guys?
Not very much.
None? I can handle none if you'll let me just write the answers.
Sure.
Are we okay with that?
Yeah.
I try to make sure if I skip steps, it's steps that I feel like everyone would be comfortable with. So x equals 0 is obviously an answer. If it's 2x minus 5, you guys, what'd you do? Add 5 and then divide by 2. So I'm going to write this answer as 5 halves. If it was 3x plus 2, you subtract 2, divide by 3. I have answers of 0, 5 halves, and negative 2/3. That's technically an algebra problem. There's no pre-cal in that. That's going back and remembering our algebra skills. I know that's digging deep, but that's all algebra skills. I didn't teach you anything new there. It's just an algebra problem you didn't necessarily like. That's the problem. Okay. So B is also an algebra problem. Square root of x plus 1 plus 3 equals 2x. At some point, yes. Yes. Okay, so Ross's comment, do we square everything? And my response was, at some point, yes. What has to happen before we square things? Get the radical by itself. And so thus Lily's comment of, to get that radical by itself, we want to subtract 3. Does this sound familiar?
Everybody needs an assist, you know.
Right.
Okay, so square root of x plus 1 equals 2x minus 3. So our job when you have one radical in an equation, move everything else away from the radical. So we square. So that means raising both sides to the power of 2. Left side's the easy part. What happens when you square a square root? Okay, the square and square root cancel each other out. You have just x plus 1. What about 2x minus 3 quantity squared? Distribute the squared in there. What do you mean?
Square both terms.
Square both terms. So what are you going to have?
4x squared minus 9 plus 9. I knew that.
Okay, you're 2/3 right.
It would just be 2x squared, wouldn't it?
2x minus 3 and then 2x minus 3.
What happens if I rewrite this as 2x minus 3
No way.
times 2x minus 3? Why would I write it out that way? What am I trying to get you to tell me we have to do? FOIL. And for whatever reason, if we write it and just leave it as a squared, a lot of times you guys miss that we need to FOIL. Right? But if I write it out, all of a sudden you guys know we have to FOIL. I'm not sure what the difference is, but it's the truth. Because as soon as I was told to write it side by side, you guys were like, oh, okay. Now, I said she was 2/3 right when she gave me 4x squared plus 9, because those are going to be 2 of our 3 terms. That's why I said she was 2/3 right. So first, 2x times 2x, 4x squared. Now, what she skipped were outsides and insides. Outsides, 2x times minus 3 is negative 6x. Insides, negative 3 times 2x is negative 6x. What's negative 6x and negative 6x? Negative 12x. So my middle term is minus 12x. And then last, negative 3 times negative 3. She did it again. plus 9. Okay. So, yes, don't forget, when you square a set of parentheses, it's really FOIL. Okay, thoughts on where to go with this problem next? Let's make it equal to 0 and see what happens. So, most of you guys know what I'm going to say. I'm going to keep the 4x squared as positive, aren't I?
Yeah.
Which means I'm going to move the x and the 1. If it's a plus x, I'm subtracting x. If it's a plus 1, I'm subtracting 1. So 0 equals 4x squared minus 13x plus 8. What's next? Okay. If we're going to factor it, again, there's an a term. So we're going to think product of AC. We would need a product of what? 32. And a sum of negative 13. 1 and 32. 2 and 16. 3 doesn't go into 32. 4 and 8. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. And then I'm at 8, which I already used 4 and 8. So unfortunately, as much as you guys were hoping this factors, we tried, which is good. It doesn't factor. What's plan B? Quadratic formula.
No solution.
Plan B is not just to stop and say no solution. That's like plan Z, to stop and say no solution. Okay, when I write my quadratic formula, I always start with x equals, because that's what I'm trying to find here. I'm trying to find x. Negative b. It's the opposite of negative 13, so 13 plus or minus the square root b squared, negative 13 squared minus 4ac all over 2a. A is 4 because that's what's in front of the x squared term, correct? Yes, 8. Okay. I saw it on the quiz. I warned you guys. I still saw it on the test, not as much, but when we go into that radical, negative 13 squared. What do you know about negative 13 squared without even grabbing the calculator? It's going to be a positive, yes? I still have people trying to tell me it's a negative. So, I'm going to get my calculator.
Yeah, whenever you put it negative 13 squared in it, puts it as negative 169.
Okay, so here's the difference. If I do negative 13 squared versus, I did not enter the same thing on my calculator there. Even though I know some of you guys are arguing, well, it's negative 13 squared both times. This part is just like your scientific calculators were. That if you put negative 13 squared with no parentheses, it's doing the negative of the square. This is where you guys have to be smarter than the calculators, is what I always say, and think it through. So if you want the calculator to tell you positive, you best put parentheses around it. Okay? So good calculator note there. Okay, so 13 squared, 169, minus 128, she says. And so what is 169 minus 128?
41.
So square root of 41 all over 8. And do notice, another mistake I see is people don't write that 2a underneath at the beginning. I don't know if they just forget it, if they think, oh, I'll go back and put it in later. Yeah, well, some people forget to go back and put it in later, so. Okay. Oh, well, some people will just write out the top of the fraction, and then they won't ever remember to go back and put it over. Like, that's a grading mistake I see a lot when I'm grading. Is they'll have their answer perfectly right if I'm just grading the top, but they never showed me the bottom. Or they put it in the beginning and just forgot to put it in the end, that type of thing. Okay, this answer, square root of 41, irrational. Okay, so answers. I was going to say, I have two different boxed answers. I have this answer, or I have the idea of splitting it up in that this is 13 over 8 plus or minus square root of 41 over 8. I have both of those written in my notes, which means I must be happy with either in this area. Depending on the problem, what if they told you that they wanted a decimal answer? You'd want to get a decimal, right? And so I would add or subtract the top and then divide by the 8. I can tell you if you needed decimals, I have them written down as 2.43 and 0.82. Okay. Good, solid algebra review. That's not the wimpy algebra either. Yeah, it's the algebra you have to think a little harder on. Okay.
Because there's the 3 equations substitution.
Oh, do we have to do that again this year? I like those.
I don't remember. I honestly don't. Sorry, my classes sometimes blur together. Right now, I can't separate. So, okay. Example 7. Notice this section says solving equations graphically, which is a good thing because as I look at example A, the absolute value of 2x minus 1 equals 3 times the square root of x plus 6. As much as we've done algebra, that's not algebra we've done. Okay? I honestly don't even know if there is a good algebra method for this one. Maybe there is, but ugh. Okay, so graph. Now, in order to graph, we need an equation to graph, yes? Right now, do I have a good equation to graph? Not really, because I have one thing on either side. When you put it into your graphing calculator, you need it to say y equals. Okay, so your number one rule when you are told to graph something like this is to make your equation equal to 0. And that's what you'll actually graph. Now, I believe, if I recall correctly, I believe in the book, it will say to make your equation equal to 0 by, I don't remember how it's phrased, but basically they want you to put everything on the left and your 0 on the right. It can make a slight difference in your graph if you don't. Does that make sense? Okay, so if I say put everything on the left, absolute value of 2x minus 1 is already here, yes? What needs to move? The 3 radical x plus 6. That's all one term. So we're just going to subtract 3 radical x plus 6. What I do on one side, we do on the other side. So when I write this, I'm going to have the absolute value of 2x minus 1 minus 3 times the radical x plus 6, and then we're going to say what? Equals 0. Okay, so now that we have it all on one side, now can we put that in the graphing calculator? Yeah, because what we're going to do, so when we go to what you're graphing, is going to basically, I replace that 0 with a y. And so we're graphing y equals absolute value of 2x minus 1 minus 3 times square root of x plus 6. That is what we're graphing. So, steps so far. I did my equation, and I made it equal to 0. Then you're going to graph y equals whatever equation. So this means I have something to teach you, don't I?
Put absolute value.
How to put absolute value. Now, let's time out before we do that. Most of you, as do I, have a stat plot still on. I honestly don't know why sometimes you can graph with the stat plot on and sometimes you can't. I honestly don't know. You want that side? Is that what you want, Levi?
No, I need the rest of the. Yeah.
Get it right down quickly, because.
Yeah, I'm good.
Okay, now notice if you look down here in the corner, I can tell I still have a stat plot on because notice my plot 1 is highlighted. And in fact, I wonder, can you go right there? No. Oh, you can. I just learned something new. I'm excited. Okay, that won't necessarily work for all calculators though. But the calculators like this, it might. Did you see how my plot 1 was highlighted? That's how you guys are accidentally turning them on. Okay, sorry.
Makes sense.
Because some of you guys, I've had to turn your stat plots off.
It works on.
Well, you can turn them
It
all
works on the
on.
normal TI-84 plus.
Okay, so right there, see like right now, all 3 stat plots are on. But if I go up, man, I just learned that. I'm so excited.
What are you pressing?
Enter. Sorry. Okay, I didn't
Yeah, I was. I pressed
was like-
ask the questions. Sorry, I was excited. I got excited, okay? You don't understand. Okay. Excitement. Okay. That's my math excitement for the day. Are we, Levi, are you good now? Sorry, I didn't. Now, the other TIs did it too?
Yeah. The normal TI.
The other, okay, so the non-colors. Okay, so are we all good? Because how did I teach you to turn on the other day? If you remember, second stat plot, and that's where I showed you how to turn them on and off the other day. Okay? So, okay, go back to your y equals screen. Absolute value. You want to know where it is in the menu or you want the shortcut? I like my shortcuts personally.
Yeah, of course.
Here's what I will tell you about menus. Pretty much everything can be found in this math menu. So right underneath the alpha button is the math button. Yes?
Yeah.
And then for absolute value, I think you have to go over, you arrow right, 1 to the num menu, N-U-M. And notice the very first thing up there is abs, ABS. If you click enter right here, that will put absolute value where you just were, which was in the y equals menu. And then you can type inside of it. Now, here's my shortcut. If I go back to my y equals, you see the alpha button? The alpha button goes with that's the green button. It goes with these F1, F2, F3, F4, F5 menus. If I do alpha, I don't remember which one. Nope. I know, so I'm trying F2. If I do alpha and F2, which is the window button, these are all shortcuts. Notice, what's the top shortcut? Abs. Now, on my calculator, I type abs, and it gives me bars. On some of the older style calculators, it might do ABS and then parentheses. And that's how that one works. And actually, if it works like that, I might be able to update your thing. But okay, so then I'm going to do 2x minus 1. I'm going to arrow out of the absolute value. And then it's what? Minus 3. Okay, square root is the second function of the x squared button on the left. So second square root. And then I type in x plus 6. We had some weird settings yesterday, so I would recommend doing Zoom 6 to get you back to a standard setting. Because otherwise you're probably only seeing first quadrant depending on what you last graphed.
And this is one weird.
Wait,
B, but it's like.
Well, but see, there's absolute value in it, right? And so then it's a V, and it's like cattywampus. Or what?
So we go to 6.
Yes, just a standard screen is what I always do. And you can just hit 6 or you can arrow down here. And your stat bar is the one. But it's letting you go, so it doesn't matter.
But do you want to use it? Do you need that in?
We don't need it right now, no. So you could, and that's where, did you just have the option to do
Yeah.
that? Right there?
Yeah, that was on plot.
Arrow up, yeah. Oh, no, that would be on now. Actually, I wonder, did you put yours in plot 2 yesterday, maybe?
No, it was in plot 1, and then I went over to the plot 2.
Oh, but plot 2, if it's defined as using L1 and L2, it's the same thing. That's probably what happened. Okay. Carly, we talked about, huh? Okay, so I just learned.
That's when I did it too.
Right here. Yeah, we turn them off, on and off, get in.
Grab this ministry.
Now it's off. It's not highlighted. Now it's all off.
Dude,
As opposed to the other day, when I did.
Why you did that?
And the other thing is, you're gonna wanna go back to the 6 because
no.
the other day, what I told you.
Nothing's going on.
Second step. This is where it's like you come the other day.
Yeah, so she'll be, they can
I do have to come back to you.
And then 6. And now you're gonna get what I have. Okay, now, am I done with this problem? No, because what do we need?
zero.
Our intercepts.
Okay, good. We need the solutions. And my question is going to be, what are the solutions? I heard intercepts. Now, to be specific, what kind of intercepts? X-intercepts. Or what we call zeros. What are zeros? X-intercepts. So, whether you call them zeros or X-intercepts, how many solutions does this problem have?
2.
2. Do we remember how to do this yet?
Yes. Yeah.
Second.
Second,
Thank you, Joyce.
and the trace button. I call it the second calc because it's the calc menu, right?
And then number 2, and then you do the last one.
And then number 2, you pick your 0. It asks me questions. It walks you through. Please take this opportunity to practice. Make sure you can do this. So left bound. I'm going to go back before my negative 1. I'm going to hit enter. It gives me that faint vertical line. Now it's asking me right bound. I'm going to go past it to the right. I hit enter. Notice my vertical lines are on either side. My guess, I just go back to that area and I hit enter. Does your 0 match my first 0?
I can't see it.
Say it.
Negative 2.361.
Yep. Negative 2.361305 is what mine says.
You only write the first 2 letters, right? Numbers.
Numbers. Yes, I have hundreds. So I have 2 decimal places. So the rest of my notes I'm going to write on here is right now we are looking for X-intercepts. And to find X-intercepts, we went second, calc, and then we used zeros. The first answer I have is approximately negative 2.36. Yes.
For the quiz and test, would you be able to help us with our calculator, like right on the board what we need to do? Or
You need to know it.
we have to know it?
And that's the thing. If you're practicing it every time in homework, it should become second nature. It's like doing something new on your cell phone.
Yeah.
You practice it, it becomes second nature to you.
I have so many second natures at this point.
Okay, second calc. Whoops, what did I just do? I'm going down to 0. Okay, left bound. I'm putting my left bound over by positive whatever this is. Right bound. Hit enter. My guess, I just arrow back to that area. And 5.6113047.
Something happened in mine.
Okay, then start again. Go second 0. Just restart.
Mine still says left.
Second 0 also has an X.
Negative 5.
Will you count?
Okay, wait. I guess second trace or second calc. Am I? Okay, my brain, I was a step ahead, wasn't I?
I don't know. I'm pretty sure you did, but it ends up saying error. So I need to put the bound.
Okay, so start over. And then go second. So left bound, back up and go left of it. Okay. This bound is not liking one of your boundaries for some reason. Make sure you go past it. Uh-huh. That should do it. I watched you. That's why it worked. I mean, honestly, who knows?
On a test, if we put like, if your equal signs, you know how you have to like, it's like roughly equal, so you have the squigglies. Will you count off if we put?
No. Okay. Now, in a way, the next three are all the same thing. Okay? In that, get the equation equal to 0, and then graph it and look for x-intercept. That's what you're doing on, does that start at number 40, I think, tonight? Because what I'm trying to figure out, do you want me to go through another one?
Nah, you don't have to.
Look at through the C and graph of failure.
Well,
behaviors.
No thought.
First, easy.
okay, so I'm sorry, I'm trying to get to, I can't find the second page of the book. So yeah, 40 to 46 are graphing. And then 51 has to do with the hidden behavior. You want to look at one of these real quick? Which one? Okay, let's look at B. Now, I realize it's in a different section, but it's still the same process. I got the impression you guys were talking about this B.
Maybe they were, but I wasn't.
I was talking about the B with the -1.
Yeah.
Oh,
The -1 just cuts that
it doesn't matter. You're just typing into the calculator.
Yeah.
Oh, okay.
I mean,
Oh, right.
Okay, that makes my life
Okay.
easier.
okay, so when I go to graph this, we want it equal to 0, yes? So I already have x plus 2 to the -1.
Yeah.
Right, that's already there.
Right.
And then x to the -1. I need to move that over.
Minus everything.
So it's going to be minus x to the -1. I need to move the plus 2x over, so minus 2x equals 0. And then you're just graphing that.
Yeah, I've been doing the same thing.
Uh-huh.
That was easy.
So you're graphing y equals x plus 2 raised to the -1 minus x to the -1 minus 2x. When I say -1, make sure you use your negative button on the calculator. Don't try and put a minus in the exponent. It'll give you an error.
I did that.
Okay? It'll give you an error, I can guarantee
Oh
it.
my goodness. I got 3 different perfect lines.
Okay, so parentheses, x plus 2, parentheses. I'm going to use my exponent button, raise to the -1. Minus x to the -1. Minus 2x.
If you were to do it like mine, I would be really upset.
I hit zoom 6.
Okay, good. Hers is good.
That's the same. Mine not here.
That's a lot of X's. Wait, no.
It's a lot of vertical asymptotes.
That's 1.
Now, how many solutions do you see here?
1.
1, because all we care about is where does it cross the x-axis. So, second tracer calc. Go to number 2, which is 0. Now, left bound. Who knows where my cursor is right now? So you just keep arrowing left until it gets to where it needs to be. Notice my cursor's up there. That's a problem, it appears. Just keep arrowing left. Left, left. Oh, hey, guess what? Now it's magically down there. Because it just continues left in terms of x values. So now, I am to the left. There's my left bound. Right bound. Basically, we want to be below it. So there's my right bound. And then my guess goes back to that area. Negative 2.205569. Yeah, I'm going to write my answer as negative 2.21. Are we getting the hang of this?
Yeah.
It won't let you go where?
Negative 2.2, is that what you got?
You don't have
Negative
to go
2.21 is what I rounded to.
No, like you won't even go there. Like when I do this.
And that's fine. Okay, so it's fine. Just hit enter. If you can't get exactly, on there because it skips, it's just how the graph is, that's fine. Yeah. The guess doesn't have to be very precise. Ow.
Oh. Okay. That hurt me.
Well, luckily my sandal, my sandal actually went up. Otherwise, it would have really hurt.
I just stubbed my toe in.
Okay, now,
What is this hidden behavior?
okay, so hidden behavior. While I'm here. So if I type, I don't remember, let's practice typing this in real quick. You guys need calculator practice. Nice part, it's already y equals, yes?
Yeah.
Y equals 3 minus. Now, if you can do a fraction bar, I would encourage it. Which my fraction bar, the shortcut, is to do alpha F1. And it gives me that n over d. And then I can do 1 over the square root of x squared minus 1. If you can't do fraction bar, because some calculators can't. First of all, if it's an 84, I might be able to update your system so you can. Okay? But the other option is if you want to be lazy, you don't want to do a fraction bar, it's division, right? So you could do 1 divided by, normally what I would say is the square root all has, the denominator all has to be in parentheses. But because there is, because the square root's there, it would save it. So,
Is there an X?
I can't find it because my thingy won't let me. It keeps saying quit.
are you talking about trying to find your,
Yeah.
okay. I thought you were trying, so you've got it graphed.
Yeah.
Okay.
It says there isn't. At least when I did the left down.
Okay, so this is the idea, hidden behavior. First of all, it might be you need to zoom in to see what's going on. Okay, this one, if I just do a trace thing for the moment. First, yeah, I just did a trace just to see. First of all, notice what's happening. As I arrow left, okay, that's going there, yes? But if I try and look and see what is that at exactly. Notice negative 1.06 to 0.17. If I keep going, what is that probably going to be at? It disappears once you get past negative 1, doesn't it? And so this is one of those weird ones you kind of have to investigate. If you try to actually use your, the actual process of finding zeros, it's not going to work. Okay, now, here's the question. Obviously, you can see it looks like they touch at what? Negative 1 and positive 1. Let's think about this. Does this make sense? If we put in 1 here, does this work? 1 squared is 1. Minus 1 is 0. What just happened? You've got a 0 where? In the denominator. Can we have 0 in the denominator? No. So does this graph actually touch the x-axis there? No. So if I recall correctly, this is probably a no solution.
Oh, very nice.
I'm trying to remember what this graph looks like.
Looks like it.
Okay. This is part B. Okay. How many solutions do you physically see?
1. Oh,
Yeah.
1 for sure right here.
One for
I think it was, I think it-
How many are right here? Can you tell just by the eyeball right here? This is one where I would suggest zooming in. Where am I at on time? If we go to zoom here, do we have time to learn ZBox? I love ZBox. Oh, you guys probably didn't even do this, did you? Okay. If you don't have a graph, that's fine. Let me just demonstrate ZBox, because what ZBox does is I hit ZBox, which was number 1. I moved my cursor.
Yeah, I don't
It's
think-
number 1 in Zoom, number 1. I've got to get through this. I'm going to run out of time, so let me demonstrate. I hit enter, and then that posted the top corner of my box, and then I go over and I move, and now I'm going to put the other corner of my box, and what's going to happen is we're going to zoom in on just that bottom of what looks like a curve there. Now can you tell better what's going on? How many times does that look like it's going to cross? It looks like it's going to cross 2. So this is the type of problem that would happen. Thus, hidden behavior, because to the naked eye, it didn't necessarily look like that. Okay? So, that's the idea of what you're doing. 51 is your problem that talks about the hidden behavior one. So, give them your best try there, and then we'll come back and talk questions tomorrow. If you didn't write the homework down yesterday, let's do it now. 11, 12, 14, 20, 21, 23. 30 to 36 even. 40 to 46 even. And 51. I will say that zoom box, when you need to zoom in a specific spot, is really helpful because it will zoom in on just that spot. So it's something to play with at some point on your calculator. And I will use it more definitely because that's one of my favorites. It's 10:13.
Can you do second trace and define the what? There's
Okay. Finish the homework for tomorrow. At some point, I'm going to have to make sure I get you guys quizzes or tests.
oh man.
Maybe tomorrow we can make sure we get that done. If you run into calculator issues, let me know. Okay, make sure you're working, getting the calculators figured out.